All right, so this is my third video explainer of the term, and the problem is 12.6, which asks if there's a 120 gram ball and a 250 gram ball, which are connected by a 36 centimeter long massless rigid rod, and the balls are rotating around the center of mass at 120 rotations per minute. What is the speed of the 120 gram ball? And to solve this problem, we need to draw a picture, which I've done below. I think it helps to organize kind of our known values, and then we're going to solve for the center of mass, figure out how far the center of mass is from that 120 gram ball, and then use that number to find the speed using that omega or rotational angular speed. So we have to know that v equals omega r, and that's what we're looking for. We want v and we have omega. We just need to find r by using the center of mass. And so we have mass 1 is 120 grams, and if we set our sort of axes here to be to make the 120 gram ball located at 0.0 or 0 centimeters, and then we make the 250 gram ball equal to 36, that kind of simplifies things, because then for our center of mass calculations, it's just the sum of it's really just the sum of m1 r1 plus m2 r2 over m, so total mass. And when we plug in the values we have, we just get 0 plus 0.25 kilograms times 0.36 meters. And we end up getting, divided by, of course, and then we're going to divide, we get 0.09, we divide that by 0.37, and so what we get is 0.243 meters. And that, because that's the majority of the 36 centimeters, that is from 120 gram ball to center of mass. Okay, and so now we have that, and that's pretty straightforward. Now what we want to do is convert this 120 RPM to the radians per second. And so how we're going to do that is, of course, we know that there are 2 pi radians in 1 revolution. And then we also know that there is, in 1 minute, there are 60 seconds. And I just flipped those upside down, but this is supposed to be that way. So then we just multiply that out, and we go 120 times 2 pi divided by 60 equals 12.56 radians per second. And our final thing we have to do, V equals omega R. V equals 12.56 radians per second times 0.243 meters. And times what we get is 3.1 meters per second. And that is our final value. You just have to remember to switch the units here. That's pretty important because that can be confusing. And remember that it's not just rotating about the center, in which case all we would have to do is switch units and multiply by the radius. It's the center of mass, and so we have to find the center of mass. And then, of course, the most helpful trick is to assign 0 and 36 to either mass, just so that the calculations are easier. The 0 just cancels out, basically, so we only have to do a little less. And yeah, that's my video explainer.